This program here is aiming to achieve basic linear regression, and in its current stage it is really rudimentary. It is basic and aims to establish a strong foundation which would later allow for machine learning and data training to happen from it. And that is exactly my objective in the long run. I aim to create a very simple machine learning algorithm that would be able to train from a large data set and give accurate results, aiming to mitigate any kind of error. Now, I'm going to show you the basic structure before giving you a very short demo of this program, and I hope within the next week or so to upload a new video with the ML aspects incorporated. So the main class includes a simple instantiation of the IMP menu. This is the name given to the improved menu, an iteration from a previous attempt. And the improved menu is quite a large class. It includes an array list which takes in x and y values which the user gives to the program. And the program would then take these values being added by this method here, which adds them to the array list itself. So the x and y values respectively will be passed as doubles and then put into the array list, with of course a error handling put in just in case, because users will be users. And finally, there will be a confirmation button which would first check if there is a valid prediction put into place. So you either ask the program to predict the x or the y, and then it would call upon the arithmetic class, which is here. The arithmetic class is also quite simple. All it does is it uses a very specific set of formulas. So what we're doing, if I will show you here, is all we're doing is we're taking beta 1 of whatever we have to be equal to the sum of x, y, so that's x times y, multiplied by n, minus the sum of x and the sum of y. And then we're dividing all of that here by n, multiplying x squared, and minus x all squared. So I'll leave you with a document that will detail how we derive this formula. But all you really need to know is that this here, along with beta 0, but in this case I've called it beta 2, so for the sake of the video I will call it beta 2, is the sum of x squared multiplied by the sum of y minus the sum of xy multiplying the sum of x, again with the same denominator, which has been indeed handled here by calling it as a common denominator. So we're just going to write that there. So these two together are then put into the y equals mx plus c formula. So that's just the y equals beta 1 of x, so beta 1 times x, plus beta 2, and then optionally plus epsilon for error handling. These will aim to give you an equation of the line, and then naturally your prediction would be put as either this or this, so x or y, and then the program would use the rearranged formula to find the other. So if I wanted to find x instead of y, it would do beta 1 of x, it would do y minus, and then beta 0 plus epsilon in brackets, all divided by beta 1. So that would be your x prediction would be y minus beta 0 plus epsilon all over beta 1. Excuse the handwriting, I'm using a mouse. So as you can see here, this has all been handled at beta 1 and beta 2, and then we have the predictions which are calculated using the aforementioned formulas. Of course, epsilon has not been included here, but it can very easily be incorporated if needed. And one last feature was to make sure if the common denominator was equal to 0. This would only happen if the x's were all the same. And in that case, of course, it would notify the user that it cannot complete the regression if all x values are constant. So let's show this in action. So if we look at our menu, this is what it looks like. We have our x values, our y values, and then our predicteds. So I have a couple test scenarios here that we can try out. So let's say we have the points, let's see, -1 and 2. We press submit to add points here. And then we have 0 and 0. We submit that. 2 and 1. And then let's say 8 and 3. 9 and 2. And then I want to predict something. So let's say I'm quite lazy and don't pay attention to what I'm doing right now. And then I just press compute values. You'll notice here it would pass the values as it should, but then it would say that both prediction fields are empty. So let's say I then add 2 prediction fields and I compute again. It says only 1 prediction field can be filled in. So it does take those into account. Let's say I'm looking to predict the x value given a y coordinate of 2. So it's going to be question mark and then 2. And if we compute this, it will give us our complete y equals mx plus c formula, along with the predicted coordinates, which are using the equations that we just talked about. And if we were to rerun this, just again, this time with maybe a nicer set of values, let's say something like -1 and 2, we add that, 0 and 0, 2 and 0, and then we want to predict 5 and we don't know what the y is. If we press compute values, we will get an equation like this, so minus 0.571x plus 0.857, and then the predicted coordinates 5 minus 2. So it does indeed do its job properly. And it's only a matter of giving some training data and then letting it work on unseen data to incorporate the machine learning aspect, along with, of course, weights that would be adjusted as it works through the data. I'm hoping to work on that very soon, but this is just a basic rundown of it. And I hope you enjoyed this very short video and hope to see you soon.